All right. So in enterprise, the way we do Kafka is we fully replicate the Kafka stream. So um, in enterprise, we have a component called a data import server that accepts connections and writes down row-oriented logs into column-oriented persistent data. The way that Kafka works is instead of accepting connections from a remote process that sends over log file data, we have a process that runs as if it were a data import server. It then connects to Kafka, gets data, and writes it down, all self-contained, as opposed to having in enterprise what's called a tailor. So there's a bunch of stuff we have to do to say where the data is stored, how to other queries get to it, and things that don't really matter for you guys. You don't have table schemas, but you have table definitions, and they're close enough to the same thing, right? That you need to have.
So Charles, before you jump into that, can you explain the difference?
So yeah, schema in Deephaven Enterprise is represented as an XML file, and it represents the columns of a table as they are stored on disk. So their data types, it gives you a little bit of extra information, like saying this column is a grouping column, so that when enterprise writes things down when it is importing them in the order that the source decided to write them. But overnight, when we move things from our intraday space into historical space, we do a process that's called a merge. And that will take the data from all of the sources, put it together, and create what are called groups. For example, if you have a lot of stock tick data, very often you care about stock tick data for the same symbol. So you would group it by symbol. So all the Apple data is together, all the VXX data is together, all the SPY data is together. That way it's very efficient, both because we write down where the groups start and end, so you don't need to read all the other data, but also because the data is then contiguous on disk. If you are reading data for a single symbol, it's all together. And that's very helpful. So the schema defines those things. When you read the table into memory, that's where you create a definition. And the definition and schema will be almost, but not quite one-to-one as soon as you read a table. But then when you do something like an update or drop columns, rename columns, do a join, you create a new table, and that table has a new definition. So, and every table will have a definition. And that definition is immutable because it says what the columns are and what their types are. You know, you can't add columns to a table, remove columns, change a data type in a table. When you do that, you create a brand new table that references the old table. So in Deephaven, enterprise, we need to create a schema because we're writing these things down permanently. In community core, you don't have schemas, but you have table definitions. And there is that same kind of idea that you'll have data that's out there on Kafka, but you need to somehow adapt that to Deephaven. On enterprise, we have a tool that will, given an Avro schema, produce a reasonable Deephaven schema. You can specify things like a namespace and table name and a few other options. There's Java doc, and I opened it in a new tab, so you can't see that, but I can just open it in this tab. Avro Discovery. The column partition is not something that matters for you guys. One of the things that we do have the ability to do is, in addition to the Avro schema, Kafka will tell you an offset partition and timestamp. And it makes sense that you might want to write those things down into a Deephaven table. So that's just part of the definition. You get a new column that is, I opened that in a new tab. I didn't realize that. I think even if I click the Java doc link, it opens in a new tab, but there's documentation. We do all of our imports with Kafka inside a persistent query on the enterprise side. I think you guys are building something that's like application mode that might be similar, but you can do all of this from a console in the enterprise side too. What's important here is you need to have a Kafka client that's created. Kafka clients, Kafka consumers, they have properties. We embed the Kafka client into the consumer, but we don't try and re-implement all of the Kafka configuration. We want to be as light as possible, not wrap things any more than they need to be wrapped. So these properties that you see here are exactly how a Kafka consumer is created in any other Java application. And, this is a very simple example. You'll see that, we're just using string keys and values. You can use any combination of serialization that you want. You might have JSON keys and string values, or more likely string or other primitive like long integer keys, and then JSON or Avro values.
So are we using a single consumer, or is it set up so that there could be multiple?
There's a single consumer. If you want multiple consumers, you create multiple ingesters, and you can do that within the same script. You would want to use hold on.
Okay, and then the multiple ingesters can all go to one table?
They can all go to one table, but different partitions. So each partition that you consume from Kafka produces a distinct Deephaven internal partition. How that will work inside of community core is something that Ryan and Christian are going to need to think about a little bit. Kafka integration. So when you create the Kafka ingester in Enterprise, one of the things you say is, well, what partitions do I care about? This int predicate for the partition filter. And Kafka partitions are just integers. So if you create multiple partitions, you're going to want to do something like, hey, I'm going to go from partition 0 to 7. And then you might have another predicate that is 8 to 15. Or you could just say, hey, I'm consumer 0. There's 3 of us, so I'm going to take 0, 3, 6, and 9. You know, anything that passes that metric or that predicate. And you know, the next guy will take 1, 4, 7, and the third would take 2, 5, and 8. So,
how resource heavy are these?
It's not. You know, each partition is going to have some amount of data. Writing that is going to take some time. A lot of it can relate to the deserialization. So, for example, if you had 300 column wide JSON, that tops out, in our experience, parsing around 40 or 50,000 rows per second. If you have simpler JSON, you'll parse a lot more. So that's why you would want separate ingesters, because the consumer is going to give you a set of records from one or more partitions. And depending on how your Kafka stream is partitioned, you would want to, you know, first of all, being able to write and have multiple checkpoints helps. We need the multiple partitions so that we can have a simple resume this particular partition from this particular offset in Enterprise. And that way we have exactly once delivery of Kafka messages into Deephaven. If you're not persistent, how you do that, there's alternative choices. Excuse me. The consumers themselves, there's also some, you know, there's some resources there. So being able to have more than one thread or even more than one process doing that, more than one machine, could be helpful. But generally, serialization and deserialization, in our experience, has been the biggest bottleneck. Paul knows some more on Belmont, you know, what they were ingesting and how many rows per second they were doing. But I don't have any Kafka numbers off the top of my head, and it's all going to depend on what the shape of your data is.
Is Avro more performant than JSON?
100%. And then if you're using specific records, those should also be far more performant than generic records. But
so you're saying POJOs are faster than Avro?
Well, Avro allows you to use POJOs. the way Avro works is there's an Avro compiler, and that will compile a POJO that implements a specific record interface.
What is a POJO?
Thank you. Plain old Java object.
Okay.
That didn't appear in a textbook.
I read a Java textbook, so.
No, that's not intentional. So I closed the wrong. I typed into the wrong address bar because I was sharing my screen. I was sharing my screen share. So Avro has two ways of deserializing data. One is that you can use a generic record.
Can you zoom in a little bit?
Yeah. All right. And a generic record has get and put for strings and object values. And it just wraps a Java map. So if you're pulling things out of it, you're doing a hash table lookup, right? So it's not the most performant way of doing things. If you take your Avro schema and you compile it, then you create a POJO that implements a specific record. And there's still going to be get and put methods that are based on an index, but they are going to actually have fields as a POJO for everything that you deserialized. And that means that you're not doing a hash lookup, you're just looking at a Java class and you get all the benefit of a JIT. So if you're looking at kind of like the continuum of performance here, JSON is going to be worse than a generic record, and a generic record is going to be worse than a specific record. So the convenient thing about a generic record is you don't need to have a compiled class. You can just take Avro data and look at it using a Java map. You don't need to do any code generation. There's no compilation. You don't need to worry about getting user Java classes into the class path of your worker of your Deephaven process. For the specific record, you need to get the user specific record class into your Java process. And then also to understand it, you need to do some code generation so that okay, this specific record field is going to be assigned to a particular column within the Deephaven table, within the definition.
So Charles, can you talk a little bit about the use case where Kafka may be like 500 fields wide, but you only care about 2?
So in those cases, that's going to depend on your serializer and deserializer. So if you're doing something like JSON, you probably need to end up deserializing the whole thing. And I think even with Avro, you're probably going to do that. There might be ways with Avro schema evolution so you wouldn't deserialize the whole thing. But in most cases, you're going to deserialize the entire 500 field record. And then there's 2 decision points there. One is you could write down just 2 fields, right? You could deserialize 500 things into an object and you can ignore anything, right? You just don't care about it, so you won't write them down into Deephaven columns. On enterprise, that's actually into files on the file system. On community core, that would be into memory. If you are going through the effort of deserializing those, you might actually want to write them to disk. And because we are columnar, if you care about 2 out of 500 columns in a table, you're not going to read the data files for the other 498. You're only going to read the 2 data files. And similarly, if you're in memory, you don't have to actually examine those other 498 columns. And presumably with barrage viewports, you can also limit yourselves to 2 of 500 columns so that we're not going to send downstream consumers junk that they don't care about. In general, from my enterprise standpoint, I want to ingest everything so that it's there, because even if this first particular use case doesn't care about it, as I'm building my data lake, my data warehouse, I want the data there so that when someone else has a use case that might care about one of those 498 fields, it's just there and they can go at it. And you get a lot of nice serendipity. If you're pulling from Kafka into memory for a particular application, for a particular use case, that's probably where you're going to think about just ignoring those 498 fields and only writing down the 2 of them, because there's no way I'm exporting it to someone else anyway. So why waste?
All right. And then the deserialization is happening on the client side, records sent over the wire.
Kafka works is it doesn't know anything about your record except that it's bytes. The key is bytes. The value is an array of bytes. They can be present or not. And for proper log compaction, your key must be comparable byte by to say that they are equal. You're a producer, you also want to have those bytes readily hashable so that they'll spread out using a hash code of those keys, as opposed to having to do more complicated partitioning yourself. But you can. What if you're a producer? There is a those properties which specify a serializer and deserializer also have the ability to specify a partitioner. So this is the first result, but you have a producer, you have keys. You just say, hey, my partitioner class is a custom partitioner, and then that gets your key. They're doing it in Scala, but Java is the same. You get your key, your bytes, value bytes, so that this has already been serialized, and then you assign an integer. They're just using a hash of department here to make it a little bit different, but mostly you don't want to have to deal with that yourself. Right? You'd rather let Kafka just blast them out on the partitions. So that's actually all the time that I have. I have another meeting at noon. So
Let me ask one question before we
Okay.
split. Do we have a way to dump tables to Kafka, or are we just ingesting?
we're just ingesting. We have the alternative in Solace, and it wouldn't be very different for Kafka.
Okay.
That basically we take a table, we turn it into JSON or something else. That something else is turned out to be client-specific text serialization, but mostly doesn't matter. What you'd need to do there is, if you're going to do JSON, we can build the JSON. Either that or we need to create POJOs from a table and then pass those to the Kafka serializer classes. And there's choices and thought behind that, in that if you think of a stream as an append-only log, what do you append to it such that you can recreate the original table? So for example, do you use row IDs, or do you have it keyed on some other value so that when you get a Deephaven update, which is an addition, modifications, removals, shifts you probably ignore for these, that you can do something useful with it.
All right. Thanks, Charles.
All right.